Okay, so we are recording and we're going to look at some basic graphs. And so all this we're going to look at today is looking at graphs and interpreting and being able to pull numbers off of them and different types of graphs. So I think I can do it. Okay, okay, got that. All right. Now, all right. Hmm. Okay. All right. All right, so you should now be able to see a chart, homework 7.1.
Yep.
Okay, good. All right, so we're just going to kind of go through some of the problems here. The downside is I don't have my whiteboard. So I'm basically going to, you should be able to see the cursor moving around. Okay.
Yep.
So I can just kind of point to things. Now, I should have done this before. It did work. All right, so I have a cool little tool that you don't have, and I can click show the whole problem completed. That is, now you should be able to see the answers as well. And this is just to expedite things here. Okay, so here's just a basic what we call XY plane. So I'm going to kind of introduce you. We haven't talked about graphing or what's called the XY plane or the Cartesian coordinate plane. These are names for the same thing. It's two number lines put together perpendicularly as such. And so you have what's called the horizontal axis and then the vertical axis. We tend to always call the horizontal the x-axis and the vertical the y-axis. You want to be fancy, it's abscissa and ordinate, but don't have to remember those terms. But what it allows us is to pick points in the plane and label them as what we call an ordered pair. Now, in an ordered pair, X comes first, Y comes second. That's the ordered part. And it's a pair, so it's two numbers paired. And it's so in this particular problem, it says the town records its low and high temperatures for 4 months. Plot the low and high temperatures for February using a coordinate plane where the X coordinate represents the low temperature and the Y coordinate represents the high temperature. Then determine which coordinate, X or Y, is larger. Okay. Now, we can see that this one's picked right here. And we got a point plotted right there. And so we want the X coordinate to represent the low. Now, when I look at this, and I see 30 here, and we can assume that these tick marks here, here, and here on the x-axis are uniform. So if that's 30, then I would basically 10, negative 10, negative 20, negative 30. So negative 20 is here. So notice this point F, if I came down, would be a little bit before negative 20. Notice the lowest temperature recorded was what? Negative what? 18. So see how that lines up with negative 18? Now this one here that was not correct, that would also be at negative 18. The y coordinate, it said it wants to be the high temperature. Notice the high temperature is what? 40 what? 2. Now this goes up to 60. And so you would be looking at here probably by going by tens, 10, 20, 30, 40, 50, 60. So here's what, about 40. Notice this is a little bit above 40. So over negative 18, up what? 42. All right, is that clear in terms of how this point is plotted? Its coordinates would be, if I could write them down, parenthesis, negative 18, comma, 42 for the y coordinate. We good there? And so the reason this one wasn't picked, it was down to negative 42, not up to positive 42. And then which coordinate is larger? It would be the y value. Okay. We're good there. I'm going to go and look at, we got a pictograph. So shampoo sales by year, 95, 96, 97, 98, 99, 2000. Notice it got a little key right here. It says each bottle represents what? 3,000 bottles sold. And which year was the greatest number of bottles sold? Well, pictorially, just visually, you would look for which one has the most bottles. And it's what? 1998. I mean, it's just that simple. And you could actually count them up if you were asked that too by counting the number of bottles. It looks like 9. So there'd be 27,000, but it didn't ask that. All right. Here we have what's called a bar graph. All right. Now, we're going to look at this next week, but bar graphs enable me to look at data that is not quantitative, but qualitative. If I'm looking at quantitative, that's called a histogram. And the biggest visual difference between a bar graph, which we're looking at right now, and a histogram is there's no, when I look down this horizontal axis here, there's no spaces. It's just numbers going across horizontally. A bar graph has spaces between the bars, because we're not dealing with numbers here. You know, it's saw, ad, studied in school, family or friend, luck or chance, each one labeled with a letter for the key. Bar graphs have spaces in between the bars. Histograms do not. I mean, that's kind of a simplistic way to look at it, but that is the visual difference. Okay. Now, what we have to do here is interpret or answer a question based on this bar graph. It says the bar graph to the right shows the results of a survey that was taken of working adults to determine how they chose their careers. Use the bar graph to answer the following question. What was the number of adults, working adults, who were surveyed? And what this, now you notice the answer is what? 85. All right, so because I've already got the problem worked out. How do we get the answer? You would go through to the top of each bar that says there are what? 15 who saw the ad. There were 20 who studied in school. There were 15 who heard from a family or friend. 5 by luck or chance. E would be what? 10. F would be 15. And G would be what? 5. And it's simply the sum total of 15 plus 20 plus 15 plus 5 plus 10 plus 15 plus 5. Add those numbers up and you get your total survey. Questions there? All right. Another one. This one's more specific. It wants to know the calories burned during what? Tennis. And so you would just go to the bar with just tennis and go up to 400. Okay, here we have what's called a line graph. All right. And it estimates sales here in millions for a company for several years. In what year are the estimated sales the least? And so you would basically here want to find the bottom point, which one that is. Here's your estimated sales, which one has the least, and then what year does it correspond? It's 1996. I mean, visually, it's just the lowest point on the graph. All right. Okay. Another line graph. Now this one, the increase in the number of trees planted from 2010 to 2011. So I go from 2010 to 2011. Now, we want to know the increase in the numbers. Now, notice this says 3. And then the next year, 2011, we're up to what? 8. Now, 8 minus 3 is what? 5. But when I look at number of what trees planted, and then in parentheses, it says what? In what? Thousands. So what that, when you see that, that says whatever number you pull here, put 3 zeros behind it. And so since the difference was 5 from 3 to 8, then I will take the 5, put 3 zeros in there, and that's where I get my what? 5,000. Easy enough?
Yep.
All right, so now we've got ourselves what they call a circle graph. You may have also heard this referred to as a pie chart. Now, how do you construct a pie chart? So this isn't part of, this is something, again, we will cover later. But how would I actually, if I had to construct one by hand, how would I construct it? You would need, first off, if you were doing it by hand, I would want what's called a compass, which I don't have one sitting right here. A compass is a thing that looks like this, and it's got the 2 arms, and I can, widen it or narrow it depending on the type of what I want the radius of my circle. I put the point end down and then spin, and I can make angles with it. So notice here, you're given this table here. You got materials cost you $11,500. Electrical is going to cost you $1,900. Window coverings $1,000. Painting $1,600. Windows $3,000. Flooring $2,200, and carpentry $13,800. And it's the cost of adding an art studio to an existing building. And I see a color coding here, carpentry, which I see what that is the largest portion of the circle. And right here at the middle here is what the center of the circle. And this is the largest. The second largest is materials. Notice that does come up with the numbers. Now, to construct this, you would do the arithmetic required for percentages. You would need to first add up all of these. Adding up all of those gives you your total cost. Well, if you add all these up, we're already right here. It says what the total cost is, what? $35,000. But how do you construct, if you were to go construct this by hand, to know this is the proportion of the what circle that would be colored in looks like pink or maybe purple. I guess it's purple. Well, the total circle here is 100%. Your percentage would be, take your calculator, which I'm going to go ahead and do real quick on my calculator, 13,800. Divide that by 35,000. And that gives me 0.394. So let's call it what? 39.4%. 39.4% of the circle is going to be shaded in this purple. Now, how do I actually do that construction? What is the degree measure all the way around for a circle? This is a basic geometry fact on the plane. One complete lap around is how many degrees? Anybody know?
360.
Did you say 60 or 360?
360.
It is 360. Yes. And James had it as well. It is 360 degrees. All right. I will go back to in a second to why it's 360 degrees, but it is, that's 360 degrees. So what I would do is, and on my calculator, I wouldn't even round it. I mean, there's where I did the division. 13,800 divided by 35,000. I got that. I would just take that decimal, unrounded, and go times 360. That tells me about 141 or 142 degrees. And I would take then my protractor, after I made my circle with my compass, take a protractor and in the circle and put the point of the protractor here and measure out 142 degrees. And then I put my angle in. And that's exactly how I would know how to shade this proportionally correct. For materials, I would then do the same thing. I would take 11,500 and divide it by my total of 35,000, get that percentage as a decimal, multiply it by 360. It would tell me what angle to construct here, and then so on and so forth, the rest. You get your total 360. Okay, so I gave you a lot more information there than what the homework problem is requiring. It just wanted the total cost, but that's how you would actually construct a pie chart. And so these are sized proportionally, and the mathematics behind it is getting the proportion of 360 degrees. So now backing up, just again, it's college, you're entitled to all kinds of information. You know, what is the degree measure? So let's just first ask, you know, historically, where'd it come from? What part of the world? Here's your hint. This became a geographically, didn't really, probably a lot of students never gave this a lot of thought until 1990. And basically from 1990 on, it has been a hotspot for the U.S. in particular. I'm looking for a country name. The first Gulf War, who was that against? Which started in 1990. Iraq. All right. So Iran, historically, going back to antiquity, was Persia. What was Iraq back in antiquity? It was not Iraq. Civilization with big long name for their civilization began with the letter B.
Babylonian.
The Babylonians. Now the Babylonians, like I said, that is present day Iraq. The Babylonians were actually a very sophisticated culture. Their numeration system, where we use base 10, their numeration system that they used was base 60. Base 60. And, you know, what's some other examples of a base 60 system that we're familiar with? How about a clock, an analog clock? You know, how many seconds to a minute? 60. How many minutes to an hour? 60. Something to think about there. Well, so now again, this is where I wish I had my whiteboard. I could actually draw this. So you're gonna have to visualize a little bit, but here's a circle. Let's just use this as a circle. And so imagine you've got yourself, they said we're a base 60 system, so it made sense to them if an angle could make one lap around and make this full circle, They, out on the circle that this angle could produce, they chopped up that circle into 360 equal parts on the circle. Again, because they're a base 60 system. And let's say, just for argument's sake, from right here to right here was 1. Then this would be 2. So 1. So, and if you've ever had a geometry course, your teacher was probably a real big stickler if you were measuring in degrees that you put 3/6 and then a superscript of 0 up in the exponent. And that was a notation to say 36 degrees. Because without it, 36 is a real number. 36 degrees is not a real number. What actually is 30 is like just what is 1 degree. It is 1/360th of a circle. It's a ratio. That's what a degree measure is. It's a ratio of, if you say 45 degrees, and that is 45 of 360 parts around the circle. So there are other ways to measure angles. If you're in trigonometry, you use radians because radians are actually a real number. Still a measurement system for angles, but so any questions on that? Again, just some historical context and a little bit of geometry. All right. So we have some other problems here dealing with what they call circle graphs. So the circle graph here shows, again, the cost of adding an art studio to an existing building. Find the ratio of the cost of materials to the total remodeling cost. To answer this, what you're going to have to do, you really don't need to look at the pie chart. You just need to look at your table here. Materials ran you $11,500. Your total cost would be adding up all these. And I don't know what that number is specifically. It more likely is not the same as the last problem. It could be. But if I switch back to the last problem, the numbers will change because of a random number generator. I'm adding them up now very quickly. 1,800 plus 2,900 plus 3,100 plus 13,800. 36,000. So it was the same number as the last problem. I would punch into my calculator 11,500 over or divided by 3,600. Or excuse me, 36,000. Get the decimal form, and then I would convert to a fraction. Or that is 11,500 over their 36,000 reduces to 23/72. So to answer this again, you would take whichever one it asks over the total and then have to reduce that fraction as much as possible. Any questions on that? So 11,500 over 13,800 reduces to this number right here. Okay, so in this one, I'm not given a table per se. Well, I'm given circle graph shows how Americans spend their time in a typical day. Sleeping 7 hours 23 minutes, leisure 5 hours 11 minutes, other things 57 minutes, personal care 47 minutes, and then I can see the pie chart plot out like this. And when it asks where do Americans spend their most time, the blue is definitely taking up the most. So if I just looked at the circle graph, I would say it's sleeping. You can also look at the table, and it's more than any of these other activities. And then how much time do they spend? It's right there. Okay. And it's the same. Circle graphs. Okay. Here we have another bar graph. And here it says, what's the most popular activity? It's got to be the one in blue. It's got the biggest bar, and which is avoid traffic. And what's the percentage given? So I can pull it right off the table here, 79%. If I look at here, it's up to 80, but probably a smidge just below the 80. This one, it says how many more workers were unemployed in January of 1988 than in January 1997. So here B is 88, here 98, here is 97. I would take the difference of the two. Now I'm looking at this. This is 8, this is 5. That would give me 3. Excuse me, not 5. 6.5 or 6.5. Now 8 minus 6.5 is 1.5. But notice this again says to the nearest, or this is what number of workers in what the thousands. And so what I would end up doing here is adding the 3 zeros to get my thousands. So not 1.5, but 1,500. Okay. Or simply move the decimal place 3 times. So 1.5, boom, 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 and that's where I get my 1,500. This one is a bar graph that compares 2 years, 2012, 2013 in red. And this one is the number of outdoor plants shipped by a greenhouse during the first 6 months of 2012 and 2013. 2012 looks like they measured in thousands, so they gave 1,000. In 2013, they shipped out, looks like, about 9,000. Now we're wanting to know between April then and February. So if I went to April, 2013, then in February 2012. So it says the answer is 1,500. Now, if I went April 2013, it would appear about 9,500. It's coming up about halfway between the 9 and 10, 9,500. In February of 2012, it looks like what, 8,000. 9,500 minus 8,000 is 1,500. Have a line graph. This is sales of personal computers. Find the number of PCs sold in 2000. And literally all you got to do is just boom, jump up here. This is what given in millions. So you would say 132.8. And then you're not going to have to add all these zeros in. You can literally just write the word million. Now, if I wanted to convert this to a number, move the decimal place 6 times. Another line graph. How many CDs were sold in 1994? A is in what? Blue. 94. Boom, go up to here. Now I've got what? 3,000 and then 4,000. Notice this is saying CDs sold in what? Thousands. That would mean whatever number I have here, add 3 more zeros. So from here to here, that's 30, that's 3,500. 3,500 plus add the 3 zeros for the in thousands, which is where that number comes from. So I want to make sure you're aware of that. So when you work these problems, if you just type in 3,000, it's going to say wrong. Make sure whatever number you come up with here, you add the 3 zeros to it. And then this will be another one like that, and another one like that, and that completes said homework. Okay. So, give me 1 second here. Settings. Okay. There. Got it. All right. And let me do one other thing. In here. All right. Okay. So the next thing I signed, I believe this is 7.1. So it'll be the last thing I signed. I put the due date for Monday. On this, you know exactly what the homework is going to entail. We've gone through it, and so hopefully you knock that out pretty quick. And uh, so if there are no other questions, that's all I really wanted to go over today. We're looking at these graphs and charts now. What we'll do is in 120 next week is look at different kinds of charts and graphs we use to represent data for our sample statistics. And so this is kind of a precursor to that. So if there's no other questions, and then that is all I have.